It's just a synopsis. Okay. Course outcomes. Okay. Student learning times, references, topic, teaching methodology, assessment, as well as a course schedule. So the course informations are uploaded in the e-learning also, so you can download. It's gonna be similar lah. Okay. Only what I'm gonna explain is here is about the test 1 and test 2 lah. Okay, about the date. I think it's already stated in the course information. So my name is Dr. Muhammad Asmandi. So you can call me Dr. Asmandi lah. So kalau ada apa-apa, cuma tarikh ni saya tak ubah pula. Dia punya lectures ni kan. So yang ni yang lama saya lupa nak tukar. Okay, so kita punya lecture today lah 4 to 5 and as well as on Tuesday, okay, 11 to 1 o'clock kan. So dekat situ kita punya lecture lah. Okay, so placing lah, bukan ikut yang ni okay. My room is N01233. Okay, I'm still not move to another new room. It's gonna be the same. Okay, dari saya mula kerja and sampailah sekarang kan. Okay, anything I am gonna upload all the course information, all the PowerPoint slides is gonna be uploaded in the e-learning lah. So and this is my emails and also the what is it? We have also the WhatsApp group, right? For those who still not join the WhatsApp group, so you can join lah. If anything's like something urgent that I cannot uh, conduct the class and I have to cancel, so saya can inform terus ke dalam group lah. Okay. So for this course, we're going to introduce about the chemical engineering thermodynamics. I think all of you, I think the prerequisite for this course is thermodynamics. Okay, I think you have to take the thermodynamic class first before you enroll to this class. Okay, so this is more to like more detail about the thermodynamics, but related to the chemical engineering lah. Okay, yang awak belajar dekat thermodynamics tu dia lebih kepada general, right? Okay, all the content maybe almost similar like content in the Faculty of Mechanicals, okay, Faculty of Civils, kan? Itu yang biasa lah. Tapi yang ni lebih kepada chemical engineering thermodynamics lah. So we will I will give lecture. We will discuss on the volumetric properties of fluids. So how can we calculate the pressure, the volume, or what else? The temperature or pressure. Okay, for example, temperature at high pressure. Macam mana kita nak dapatkan uh, apa ni? Temperature lah, ataupun volume, ataupun composition. Okay, so kalau awak belajar mostly on the mass balance, you ada belajar juga dekat mass balance kan? In term of you use what is it? Compressibility factor, okay, PV equal to ZRT to calculate the thermodynamic properties at the high pressure or high temperature kan. So we not consider uh, the ideal gas. We did not consider the ideal gas. Okay, and then heat effects, heat of reaction, heat of formation, latent heat. Okay, what else about the heat? Heat of combustion, right? Okay, thermodynamic properties of fluid and also thermodynamic properties of the solution. So uh, three chapter 3, chapter 6, I think is more on the pure substance, and then we're gonna have a mixture lah after that. Okay, so on the solutions and how to calculate the thermodynamic properties when involve a two phase and also more than one components. Okay, and then physical and chemical equilibrium this is when involve the chemical reactions. Okay, so this one is mostly we cover in chapter 13, the last chapter. So it consists of the 5 COs. Okay. Yang pertama adalah identify and describe the thermo. This is just more related to those of chapter. Generally, CO1 is going to be related with the chapter 3 and chapter 4. And then CO2 is going to be chapter 6 and also chapter 11 and 12. Okay, and then chapter 3 is more to equilibria, is a chapter 10 and chapter 13 lah. Okay. For the main textbook, we use new versions, new edition of the textbooks, which is 8 editions. For those who have 7 editions, uh, the old version, right? This one is even for me, I'm referring to the old version of the main textbook. Okay. The content is the same untuk main textbook, untuk new edition. Um, Only some part is apa ni, dia punya susunan chapter tu dia lain lah. Okay. Tapi tak apa, nanti kita akan. Okay. Sebenarnya tak ada banyak beza pun. Okay. And then chapter CO4 and CO5 is about the communication during discussion in group and also discuss the problem given in team. This one is more to assignment lah. Okay. I just want to inform you that the assignment is you have to submit individually lah. Okay, you have to submit individually through the e-learnings. Okay, within the uh, before the deadline. Okay, selepas deadline saya, untuk semestinya saya memang tak akan buat extension for the untuk siapa yang tak submit before the deadline lah. Okay, itu yang awak kena tahu. Saya tak akan entertain lah selepas deadline tu. Okay, yang ni saya kena strict lah. Maksudnya for those who register, who enroll in my class 39, so you kena submit lah. Okay, ada 39 student, saya takkan entertain. Saya tak nak buat group lagi macam yang lepas-lepas sebab ada isu lah. Bukan nak ada isu, boleh je. Kalau you nak discuss among you when you want to complete your assignment, right? When submit individually, it doesn't matter. Except kalau this course have a project, yes, I think I have to distribute the uh, uh, all the team members lah. Okay. Ini student learning tahun 120. Yeah, face to face is me and you, and then you have to self-directed learnings. Okay, you kena study sendiri lah. Okay, lepas tu continuous assessment and final exam, or this one is contribution, is continuous assessment is I think test one and also final exam. So this is the 7th edition, actually, 7th edition of the main textbook. The new one is the 8th edition. If you look at, I think I have posted in the e-learnings. Okay, how can you get this the main textbook? Kan? So you just you can personally WhatsApp the supplier, okay, Mr. Sam. Ataupun you just use that website lah. Okay. I think all of you know how to get the what is it? Shopping online kan. Okay, you dah tahu kan macam mana, sama je. Okay. Tapi kalau you kata macam more information about the other main textbook, macam maybe other related main textbook kan, untuk subjek lain, you boleh message Mr. Sam. Okay. He provided the ni juga kan, the WhatsApp number, right? Okay, the phone number. And I also use the introductory chemical engineering thermodynamics. So this one is just a side reference lah, not main textbook. We use a Smith Van Ness Abbott. Okay, but for new one, I think there is another one author. Okay, so for the 8th edition, the color is a dark blue. So this is another reference lah. So if you interested, you can go to library to get this textbooks lah. Okay, so this is the content from the 7th edition. Okay, but from the mana? Uh, the new edition, okay, tajuk dia still sama, cuma dia, saya rasa dia ada yang ke sana ke sini, saya tak pasti. Okay, saya pun dah lama tak tengok yang new edition. Okay, tapi sama je dia punya tajuk kalau saya tengok tu. Cuma dia ada tambah satu chapter, saya rasa. Okay, first chapter is just introduction. I don't think so I'm gonna explain. I'm not gonna be highlight this for this chapter lah. Just go through, okay, briefly explain, and mostly you already learn in the thermodynamic class and also mass and energy balance. Okay, so this is just like an introduction. What is the force? What is the first law of the thermodynamic? Second law of thermodynamic. So that is just a little about the theory. And then volumetric properties of the fluid, chapter 3. Okay. PV equal to ZRT. That one is the main. How to calculate at high pressure, right? Z, how to find the compressibility factor. Heat effect. Okay. Thermodynamic properties of fluids, chapter 6. I don't remember. How to calculate the enthalpy and also Gibbs energy, I think, mostly. Okay. As well as entropy. Entropy, yeah. Okay. So I think this the step how to calculate the hypothetical part. I think you learn also in the mass balance. Okay, in general. And then solution thermodynamic and also solution thermodynamic theory and application, chapter 11 and chapter 12. Okay. The uh, after chapter 6 is chapter 11, 12, and then we go to chapter 10. You have to remember that chapter 10 is more to a physical equilibrium for the binary system. Okay, so for the chapter 11, we focus on the fugacity, and then chapter 12 is more to activity coefficient. Okay, this is for the solution because it's already involving two phase and also more than one component. Okay, and then chemical reaction equilibrium when involve the chemical reaction. Okay, I give a lecture and then some tutorials we're gonna discuss. I don't think we have a group project. Yeah, and then we will discuss. I give the tutorials and you do in my class. Okay, test one. Okay, assignment. This is the grading for this course. Okay, I think the for the assignment is 20%. Test one, 20, test two is 20%. Okay, if you look at the course information, I didn't put the schedule, I think, the date in this slide. Saya rasa test satu week 8. Okay, after mid semester break. Sebab mid semester break is a week 7. So meaning that week 8 is on 11 lah, on the Wednesday at night. So we will conduct this test one. So please block this date. Okay. Jangan cakap nanti tiba-tiba you clash. Saya tak nak. Saya dah block dah date ni. Okay. And then test 2 on June. Okay. Test 1 on the May 11. May 11. Okay. Ya yeah, betul. May 11. And then June week 12. Okay. Week 12 May bila ni? 8 Jun. Okay. 8 Jun. Okay. So 8 Jun. You block to date. That tarikh tu. Nanti kalau lecturer tanya awak dah ada test termong. Jangan tiba-tiba pula saya nak kena tukar. Saya biasa memang first class. Saya dah kasih tahu tarikh dah. Tapi student selalu kata ada test lain. Selalunya saya takkan entertain lah. Sebab saya memang dah kasih tahu awal-awal kan. Itu tak boleh lah. Siapa yang tak datang tu kena inform kat sini. Awak kena inform. Dah kenal ke? Awak dah pernah masuk UTM ke? Dah pernah masuk UTM dah? Ni tahun ke berapa? Saya tak ingat lah. Awak punya metric card apa? Sekarang kat UTM. Oh, okey, dah boleh masuk. Okey, okey, okey. Bagus lah. Tahun 2. Okey, okey, okey. Dah masuk Bagus, bagus. Enjoy your life in UTM. Saya itulah. Sepatutnya bila masuk universiti kena ada live universiti kan. Kan nak online kan. Masih nak online dari rumah je. Saya pun tak seronok lah. Okey. Mana ni? Habis. Itu je. Ni saya dah upload kan. Tu block that date. Okay. Any question about the assessment, about the CLO? Okay, for chapter 3, next class lah kita akan, hari ni chapter 1 saya just explain briefly, awak boleh baca apa yang you nak ni. Tapi kalau biasanya kalau untuk macam prefix kan, conversion of the unit, sepatutnya awak dah tahu dah tu. Okay, takkanlah saya nak explain kan. Ada soalan tak dia? So if you have question, you can unmute lah.
Hello, Doctor, can you hear me?
Okay. Saya dah upload chapter 1, chapter 3 kan. Nanti saya Chapter 3 saya dah upload. Okay. So kita hari Selasa lah. Saya akan kasih lecture on hari Selasa chapter 3. So uh, so untuk hari ni ni. Okay. So chapter 1 is the introduction lah. Saya just go through je lah. What is a thermodynamics kan? Apa itu thermodynamic properties kan? Itu je lah. So biasanya ada zero law, first law, second law, third law kan? Okay. Tahu kan? Zero law, first law, second law. Second law is more to the what is it? Entropy lah. Selalunya kalau kita nak entropy ni contohnya degree of randomness ni maksud dia mana? Contohnya conversion daripada solid ke liquid, liquid ke gas. Okay. So dia punya direction tu kalau solid ke liquid kan senang kan. Okay. And dia secara natural dia. Okay. Degree of randomness. Maksudnya kalau daripada liquid ke gas, dia senang lah. Berbanding daripada gas ke liquid, liquid ke solid. Perlukan lagi energy. So selalunya kalau untuk reaction kita perlukan positive entropy lah and negative entropy. And negative gives energy. Okay, sampailah dia apa tu? Equilibrium. Okay. Zero law, second, first law ni awak dah belajar kan? Okay, energy balance. Takkan tak ambil lagi energy balance. Okay, types of process application. Kalau tengok kat sini, combustion, power, chemical reaction, equilibrium, balance, phasing. Okay, awak kena ingat thermodynamics. Dia kalau dalam chemical ni, dia kena selari in parallel with the chemical reaction. You tak boleh, kalau nak design reactor, you nak consider thermodynamics je, tak boleh. Kalau reaction ni, kinetic ni, kita nak tengok how fast your reaction can go. But thermodynamics, kita nak tahu optimum, paling optimum. Walaupun you increasekan you punya temperature sampai 1000, belum tentu lagi awak boleh dapat you punya desired product. Okay, because the possibility is going to be converted into by product, which is undesired product lah. Okay, and you punya yield lagi rendah berbanding kalau you contohnya you buat reaction, dia punya optimum condition adalah just 600. Okay, so you can get a higher selected product rather than at 1000 degrees lah. Okay, heat balance, phase equilibrium, this is important for the thermodynamics. Okay, thermodynamics not only on macro scale punya process. Macro scale ni maksudnya thermodynamic macro scale. Tapi under molecular level pun thermodynamic is important lah. Okay. Quantum, thermodynamic is important. Okay. Sebenarnya dia ada orang panggil apa relationship antara makroskopik dan mikroskopik lah. Okay, kalau kita derive equation yang makroskopik tu kita akan dapat yang makroskopik punya level lah. Tapi more tu kalau kita consider the ideal lah, ideal condition. So, why is the thermodynamic is useful? Is required for physical and contohnya macam distillation kan. You nak separate, dia kena dalam keadaan equilibrium. Macam mana kita nak separate? Okay. So, this importance lah, mass transfer. Okay. Especially the ni lah, orang panggil apa ni? Distillation column lah. Okay, bila melibatkan banyak phase kan. Okay, nanti bila you belajar pada tahun keempat nanti, ke tahun ketiga, you akan belajar plan design kan. Okay. Okay, dekat situ you akan guna software Aspen HYSYS. Okay, kalau yang tu you just pilih je kalau untuk pressure ke untuk calculation of the thermodynamics, biasanya you akan pilih Reddick Kwong kan. Okay, ataupun soft Reddick Kwong. Okay, tapi teori behind the equation is yang ni lah, macam mana you guna equation tu kan. Okay, tapi bila you guna software you just masukkan all those parameters lah for the thermodynamics lah. And what is the justification you use Reddick Kwong, soft Reddick Kwong kan? Compare with the Peng Robinson, okay, is gonna be difference. Okay. Okay, ni yang saya katalah tadi, thermodynamic is how far you can go until optimum condition, but kinetic how fast is your reaction. So this is a two main concept that you have to know lah as a chemical engineer. Okay. So example ni kan, ni kalau you nak manufacture of ethylene glycol kan, okay, so most effective up to 150, okay, So you need to design the preheater lah before we apa ni, before enter the reactor. Okay. So we need to know the knowledge of the thermodynamics lah. Okay. And if you look at here that the change in enthalpy is only 24.7 kilocalorie per gram moles lah. Okay. Okay, kalau kita increasekan lagi temperature, nampak sebenarnya CO2 lagi increase. Thermodynamic, the knowledge of thermodynamic ni yang penting. You tak boleh increasekan lagi you punya temperature sebab nanti you punya byproduct ni lagi banyak, kan? Okay. So heat is removed from the reactor. T does not rise much above 250. Okay. So we have to find the optimum condition lah. Okay. So when you want to design the reactor, you need the knowledge of the heat transfer. Okay. Okay, sama juga after that you have to do the condensations or you have to do separations. This is all this thing is involving the phase change, okay, hydration reaction and also dissolution process. Okay, so itu yang you kena tahu heat, latent heat. Kalau phase in change ataupun temperature change but phase sama kan, what heat equation apa yang you perlu guna untuk latent heat. Okay, sensible heat equation mana yang you guna. Sebab reaction dia contohnya macam air kan. Walaupun pada temperature yang sama, okay, phase boleh berubah kan daripada solid ke liquid. Tapi temperature room temperature je, kan? Okay, faham tak? Okay, sama juga kalau you increasekan temperature tapi phase dia tak berubah kan. Okay, itu dalam case you nak for the water and also ice lah, as well as water vapor lah. Tu awak kena tahu. Heat tu different. Okay, sama ada phase change, temperature constant, temperature change, phase constant kan. Okay, and then there is another reaction pula. Okay, so this is the thermodynamic properties that you're gonna deal for the next, starting from the next class. Okay, what is it I think volumetric properties is gonna deal first with the pressure, temperature, PV equal to ZRT. Kan? Yang tu yang basic lah. Pressure, volume and temperature. Okay? Pressure, volume and temperature. Okay, but the main thing is how to determine the compressibility factor. Kan? So kita akan gunakan apa? Cubic equation of state. Equation of state. Okay? Ideal gas equation, we call it also equation of state. And equation of state we can divide it into virials, then cubic equation of state as well as ideal gas equation lah. And then we can use a vapor liquid equation. Okay. Okay, first law, second law. This one is I think the first law, I think you know, okay, about the conservation of energy. Second law more to entropy. Okay, delta S equal to Q divided by T. So meaning that the need to be positive lah. Naturally you can convert lah. If not, we need externals panggil apa? Yang membantu kan, supaya dia contohnya daripada gas ke liquid kan, so more energy. Okay, phase equilibrium relations. Kalau you nak tahu dia punya fugacity, phase equilibrium ni penting tau. Fugacity dekat vapor dengan liquid ni lain, komponen tu kena sama. F alpha dengan F beta and F infinity kan. Sebab tu this is fugacity, kalau kat sini adalah fugacity species in solution. Dia ada species dalam solution tu. Dalam liquid, species dalam liquid, species dalam vapor. Kena dalam equilibrium sah baru you boleh separate benda tu. Okay, and then chemical reaction equilibrium. Okay, this one is chapter 3 lah. Chapter 13. Yeah. And then dimension and units. I don't think I'm gonna explain this one. Okay, I think all of you know how to convert from the Americans unit to the SI units. Right. If we give you SI units, so you know how to convert it to the American unit and American to the SI. But mostly for the apa is it, textbook mostly they use the SI unit lah. Tak macam saya dulu lah. Dia orang bercampur-campur. There are some chapter they use the American unit, some chapter they use apa ni, SI unit, especially mass energy balance book lah. Tapi sekarang saya rasa semua buku guna SI unit. Okay, prefix. Okay, I don't think it's gonna explain. As well as the volume, amount and size. Okay, how to convert volume. Okay, molar volumes, density, mole. Okay, weight. Okay, I don't think. Okay, force F equal to ma. Okay, this one is nothing. Second law. Temperature, how to convert to Fahrenheit, Kelvin, Rankine scale. This one is I think even if you use the what is it, the calculator, scientific calculator, right? Okay, I don't think you need this equation lah. Just use you input the symbols, okay, and then you can calculate if you want to convert from the degree C to the Fahrenheit scale. Okay, it's just a relationship. Pressure also SI and also English unit. English American lah saya panggil. Some book they use a British unit. British lah. Some book they use the English unit. But we call it as a non-SI lah, SI unit. SI is standard, international standard punya kan. Okay, measurement of the pressure, okay, work W, okay. P, nanti you akan belajar work. Saya rasa dekat Mass Energy Balance you dah belajar kan. Work equal to integration of P dV kan. Okay, yang tu lah. Okay. Yes, this one P dV and VdP. Okay, so you boleh dapat lah. Energy, this one is kinetic energy, potential energy, you dah belajar. So saya takkan ni lah. Okay, nanti heat, for the heat, kita akan belajar banyak lah. Heat of combustion, heat of reaction, sensible heat, latent heat. The equation is going to be different. Okay, we cannot simply use only one equation for all the heats lah. Okay, you have to know how to differentiate the latent heat, sensible heat. If the reaction occur at 200 degrees C, 1 atmosphere, and then the final condition is 200 degrees C, okay, 5 bar. Okay, how can we calculate the total enthalpy lah, change in the enthalpy? So we cannot simply calculate delta H from the initial condition to the final condition. So we have to use the hypothetical part, okay, because we have to consider the change in temperature, change in the phase, whether it's a two phase or uh, only solid, only liquid or vapor, okay. Because mostly is the mixture is gonna be many component and involving two phase, vapor and also liquid. So itu kena tahu lah. And then daripada liquid ke liquid to another condition lah. We call it the hypothetical part lah. Okay. Generally you dah belajar dekat energy balance saya rasa. Okay. Any question about this one, the introduction? I hope that you can read first my PowerPoint slide. Okay. For chapter 3. Yeah. So mostly on the how to calculate the volumetric properties lah, thermodynamic properties, PV and also T. Yeah. So from that we know how to use which equation is for the low to moderate and moderate to high, because generally for low pressure we just use the ideal gas, and at what condition we can use the ideal gas equation, yang tu kita akan tengok. Okay, not simply you dia ada range dia. Okay, bila you calculate Z tu between dia ada range dia lah Z tu. Okay, you tak boleh simply use that ideal gas equation, because there's a condition or assumption for the ideal gas and also the real condition. Okay, why we did not use ideal gas equation for the real condition. Real condition meaning that your condition is higher temperature, high pressure lah. Okay, so you have to consider pressure ni tak akan ada low reaction ni. Kalau dekat power plant dia akan tinggi kan. 600, 500 pressure is gonna be more than 5 bar. So kalau you guna ideal gas equation, memang you punya value akan tak accurate lah, lari lah. Okay, ada soalan? Is it clear before we stop? So far no. Okay. Ada Any questions? Okay, siapa yang belum join WhatsApp group, bolehlah untuk kawan-kawan awak yang tak tahu boleh join group WhatsApp group lah. Okay. Okay. So, alamak, kenapa saya punya ni tak boleh jalan ni? Attendance. Kenapa? Okay, kalau tak ada soalan, itu sahaja untuk hari ni. Okay. Textbook you boleh ni lah. Beli online. Kalau tak, dulu saya kena order daripada Mr. Sam tu. So sekarang bila ada online, senang lah. Academic advisor, sekejap e-learning. Anyone still not scan the QR code for the attendance? Ada tak? Okay, itu saja hari ini. Please scan QR code for those who yet scan this attendance for the attendance. Okay, thank you very much. I'll see you on Tuesday. Okay, so please read the chapter 3 first, and sub tutorial we're gonna do together. Okay, guys, thank you very much.
Thank you, Doctor.